Hi everyone, and happy Pride Month again. Science Daddy back with you, and this time we're going back to my old favorite, Insight. Get the beard out of the way, yes. Um, yes, and it's freshly red, Mars colored. So in addition to this past week having some really awesome news about Venus and the selection of Veritas and Da Vinci missions, Insight also did something kind of clever, and it's worth talking about. This isn't about the mole. I'm in the process with my colleagues of writing two peer-reviewed papers that discuss the mole and the stuff we discovered on Mars, and lessons learned for future penetration attempts. So I'm kind of having to relive all of that, and it's okay. But has to be done, and maybe it will provide closure. But anyway, Insight, the rest of Insight has been doing great stuff. It's still listening for Marsquakes. It's still measuring temperatures and pressures and winds, and just doing really great science. But things are getting kind of tough for Insight right now, mole difficulties notwithstanding. So this is what Insight looked like just after we landed. I mean, this is a picture looking past the UHF antenna. SEIS is still on the deck, and there you can see the solar panel. You can count the individual solar panel cells. It's great. This is what it looks like now. It's covered in dust. There's Mars is a very dusty place. Sometimes there are big global dust storms, but even when there aren't, dust gets kicked up around the planet, gets transported long distances in the atmosphere, and then slowly settles out. And from decades of work by the Spirit and Opportunity rovers and Pathfinder and such, we have good models of how rapidly the dust settles out on the solar panels, or any surface really. And so we built Insight with solar panels large enough, and there's even some solar panels on the deck as well, so that after a full year of dust accumulation on Mars, it would still have enough power to keep operating. And that full Mars year, 2 Earth years, we've passed that point, and Insight's still going. So well done to the engineers and the modelers. And people often ask, why don't we provide some sort of cleaning mechanism for the solar panels? And I actually made a video about that some years back, and there's a link to it in the description. But it's still a problem. The dust, we didn't have the money on Insight, essentially, to come up with some sort of dust mitigation strategy that would fit within our budget and also be safe and that we could test thoroughly. So what do you do when, it's getting dusty there, and the dust devils and things that come pass by Insight just aren't as powerful as the ones that were happening at Spirit and Opportunity, so we haven't had any natural cleaning events. It's becoming a particular problem right now, the dust accumulation, because Mars is approaching aphelion. That is its largest distance from the sun. This is not quite winter, as we think of it, because on Earth, winter has to do with which pole is facing closer to the sun, north hemisphere, south hemisphere. But on Mars, there's a much bigger difference in its orbit. Earth's orbit is pretty circular, whereas Mars is much more elliptical. Here's a graphic I got, the reference is down here. This is an excellent figure, and it shows the distance from the sun at perihelion, when it's the closest, 1.38 astronomical units, 1.38 of the average distance between the Earth and the sun, and then at the greatest, it's 1.67. So that's a difference of 43 million kilometers, or 4 gigameters, if you like to use, metric names properly, and then Earth, 6 million kilometers, or 6 gigameters difference. So it's a much smaller difference on Earth. So on Mars, aphelion is really the coldest time of year. And as we approach that coldest time, more and more of Insight's available energy, which keeps dropping as the dust keeps collecting, has to be spent on keeping it warm, keeping the electronics and everything warm enough to survive. Which means we don't have enough power to operate all the instruments at the same time. We have to pick and choose, and some things get turned off. And you lose science when that happens. It's unfortunate. So, what are we doing about it? And what did we do cleverly about it? Well, since we bid farewell to the mole, we've been using the knowledge we gained of scraping and scooping up regolith to bury part of the seismometer's tether. We've been doing lots of these scrapes with a robotic arm, just here between HP Cube, which is off screen, and the seismometer's wind and thermal shield. And we've been dumping the dirt here on the pinning mass. This is a mass that's on the tether, and it's a thick tether, and it's got some stiffness to it, so it kind of bulges up above the soil. And we think it might be catching wind and contributing somewhat to noise in the seismometer. So in order to eliminate that and provide some protection as we go into the winter time, the aphelion time, we've been scraping up dirt and dumping it on the pinning mass, and you can see that it's getting pretty well buried there. Great. That's not what we did the other week. The other week, we took a scoop of dirt, brought it over to the deck here, and dumped it on a cable on the deck. And there was some interesting speculation on the Insight subreddit about why we did this. I was like, I want to tell you, but I can't tell you. But now there's been a NASA press release about it, so it's public knowledge, and I'm going to tell you about it. We used dirt to fight dirt. We used properties of sediment transport in wind, aeolian transport, to clean some dust off the solar panels. It's absolutely brilliant. So after a year, Mars year's worth of observing with very sensitive pressure and wind sensors, we know what time of day is the windiest and what direction the wind typically blows. And what we could do is we scooped up the regolith, which has some dust in it, but for the most part, it's sandy material. It's coarser. We brought it over and we dumped it on the deck. Now, dust, as we know, it distributes through the atmosphere. It's very fine. It gets suspended in the air. It just stays aloft until the air is really calm and it slowly settles out. There's another type of aeolian transport called saltation, where winds can pick up granules and they will fly some distance and then re-impact into the ground. Sometimes they'll stay there, sometimes they'll bounce again, get re-entrained by the wind, and so on. There's a lot of great figures of this around the internet, but here's one of them. So fine particles get suspended in the wind. Coarser particles will saltate, hop along the surface, and really denser particles will get hit by those saltating particles and can creep along the ground. This all depends on the density of the particles and the speed of the wind and the density of the atmosphere and all those things. But the basic principle is the same. By mobilizing sand over the solar panels, we are able to knock away some dust. And so that's what we did. Here's a movie of that process. We brought it over. And watch, when the dump happens, watch the solar panel here on the left side. So we go over, see how dark it lightens up, or it darkens up rather. The dust gets removed from it. I'll show you again in just a side-by-side comparison. So this is before the dump here, and this is after. And it looks darker, and you might think, oh, darker, there's more dirt on it. No, actually, the dust has been removed. We actually saw an instantaneous jump up of the power being produced by the solar panels when the dump happened. And it was enough of a jump that it might mean a few more weeks of InSight operation before we have to go fully into hibernation mode. So, yeah, how cool is that? We used the dirt, which I've learned to hate. Not really, but you know, it's like, the freaking dirt just causes so many problems. But here we're using it to solve a problem. We're using it to kick away dust on the solar panels, which is, you know, it's sticky and adhered to it, it's staticky and all this other stuff. But, you know, a little bit of sand just cleans off some of it. It's not pristine, but it worked. And excited to see we try it again, and maybe our hibernation period, where we have everything in safe mode, will be shorter because of it. So that's really cool. And congratulations to the team for this really clever, low tech, but it used scientific principles and our engineering know-how of scooping up the dirt from what we did with the mole, and how it's just awesome. So thanks for listening.